we are now going to look at how we are going to make a Punnett square, or not Punnett square, pedigree when we are given that information. So it says create a pedigree for the following family, then label the inheritance pattern and the genotype of each family member. So we're going to start by just drawing the pedigree. So it says John and Shauna are married with 2 sons and have 3 daughters. So John is going to be a guy, so we draw a square. Shauna, girl, they're married, so we have that mating or marriage line. Then they have offspring. It says they have 2 sons, so I'm going to put 2 squares on here. And 3 daughters. 1, 2, 3. One of their sons, Doug, is married to Alicia, and they have 1 son, Damien. So we're going to say this is Doug. We're going to draw a marriage line for his wife, and they have 1 son, which is Damien. So we have John, Shauna, Doug, Alicia, and Damien. Doug's sister Elizabeth is also married. So say this is Elizabeth over here, and has 3 daughters. So again, daughters are female, so we are going to draw 3 circles. So now we have our family tree drawn. We just need to get information about the actual trait. So it says John, Shauna, Doug, 2 of Doug's sisters, but not Elizabeth, and Doug's son, Damien, are affected with achondroplasia. So they have the trait we're looking at. So we are going to shade these people in. So John, Shauna, Doug, 2 of Doug's sisters, but not Elizabeth, so this is Elizabeth. So we are going to shade in the other daughters. And Doug's son, Damien, are all affected. So we have our pedigree drawn. We now need to determine the type of inheritance. So I'm going to pull out our decision tree here. So are more males affected? Let's see, we have 1, 2, 3 females and 1, 2, 3 males. So no. Now we need to look and we need to find 2 parents that are the same but opposite of their kid. Well, John and Shauna are the same and they have kids that are opposite of them. So that will work. And the parents are shaded, so this is going to be an autosomal dominant trait. Right? So what we have to do now, because it's autosomal dominant, we are automatically going to label John and Shauna as heterozygous. And their 2 kids that are opposite them as homozygous recessive. And again, just like in the last videos, everyone who is not shaded is going to be homozygous recessive. Looking at John and Shauna's children, we know that they all have at least 1 big R because they have the dominant trait. We cannot tell if they got a big R or a little r from the other parent, so they're all R question mark. Looking at Alicia and Doug's son, Damien, we know he has at least 1 big R from his dad, and because he's shaded in. He has to get a little r from his mom, so that is going to be his genotype. He is going to be heterozygous. Our second pedigree here. Again, it says create a pedigree for the following family, then label the inheritance pattern and the genotypes. So we're going to start by just drawing out the family tree again. So Corey and Ainsley are married and have one daughter, Adeline. So we have Corey, we have Ainsley, we have Adeline. Corey, Ainsley, Adeline. Adeline is married and has 4 sons. So we're going to give her a husband and 4 sons. One of Adeline's sons, Jacoby, is married and has 1 son and 1 daughter. So we will say this is Jacoby. He gets married. He has 1 son and 1 daughter. Let me just make sure that this is still in frame. Okay, there we go. So now it says Ainsley, Jacoby, and one of Jacoby's brothers has cystic fibrosis. So we are going to shade in Ainsley. We are going to shade in Jacoby. And we are going to shade in one of Jacoby's brothers. It does not matter which one. We are going to look at our chart again. Are more males affected? Yes, but not quite. It's kind of even, so we're going to go for no. Find 2 parents that are the same, but their kid is different. So if we look here, Adeline is married to a guy who is the same, but she has sons that are shaded in. Because she has sons that are shaded in, this is going to be an autosomal recessive trait. So we automatically know that Adeline and her husband are heterozygous, and her 2 sons here are homozygous recessive. This also means that her mom is homozygous recessive, Ainsley. Looking at Adeline's dad, he has to have a big R because he has the dominant trait. But because he only has 1 kid and that kid does not have the recessive trait, we do not know what his other allele is. The same thing goes for Adeline's other 2 sons. But this is because they have 2 heterozygous parents. So they could be getting a dominant allele or a dominant and a recessive allele. There's no way of knowing. This woman that marries Jacoby has to have at least 1 big R, but we do not know enough information to figure out her second letter, her second allele. Their son and daughter also have to have at least 1 big R. They are going to get that big R from their mom. What they are going to get from their dad has to be a little r because he is homozygous recessive. So these 2 kids are going to be heterozygous. So that is how we make a pedigree and determine the inheritance type and the genotypes from there.